For millennia stretching back to the dawn of civilization, humans have sought ways to glimpse the future, driven by an innate curiosity and a deep-seated desire to understand what lies ahead. This quest has manifested in countless forms, from ancient oracles, shrouded in mystery and revered for their pronouncements, to mystics with crystal balls peering into the swirling depths for answers. These practices, though varied, share a common thread: the yearning to pierce the veil of time. Our need for foresight is timeless, a fundamental aspect of the human condition, driven by the desire to prepare, anticipate, and control our destinies. We seek to mitigate risks, seize opportunities, and navigate the complexities of life with greater confidence. Today, our crystal balls are built from silicon and code, representing a technological leap in our pursuit of foresight. We are now using science and artificial intelligence to interpret vast streams of data, unlocking patterns and insights that were once hidden from view. We forecast hurricanes, predicting their paths and intensity with increasing accuracy, stock markets, attempting to anticipate fluctuations and trends in the global economy, and pandemics, tracking their spread and developing strategies to mitigate their impact. But these predictions are not delivered with certainty, but with probability, acknowledging the inherent uncertainties of complex systems. Unlike the oracles of old, who claimed to possess absolute knowledge of the future, modern prediction tools don't promise absolute answers. They offer something more nuanced and realistic. They offer measured likelihoods, quantifying the range of possible outcomes and their associated probabilities. This shift from certainty to probability represents a profound evolution in our understanding of prediction, reflects the complexity of the world we're trying to predict, a world characterized by interconnectedness and constant change. In this story, we'll explore how AI quantifies uncertainty, providing us with a more sophisticated understanding of risk and opportunity. We'll meet human superforecasters, individuals with an exceptional ability to predict future events with remarkable accuracy, and examine classic methods for navigating the unknown, drawing upon centuries of accumulated wisdom and experience. We'll see why perfect prediction remains out of reach, a testament to the inherent unpredictability of complex systems, and why the real goal is to navigate uncertainty with better tools, strategies, and a deeper understanding of the forces at play. The quest isn't for a flawless crystal ball, a mythical object promising absolute certainty, but for a sharper map, one that accurately depicts the terrain of possibilities and a more reliable compass, guiding us through the fog of uncertainty with greater precision and confidence. Let's begin our journey into the art and science of seeing the future, embracing the challenge of uncertainty, and striving to make better decisions in an unpredictable world. When we turn to AI and ask it to gaze into the future, seeking insights and predictions, we often crave simple, definitive answers, a straightforward yes or a clear no. We want certainty. But instead of absolutes, AI responds with probabilities, offering a nuanced perspective. There's a 70% chance of rain, it might say, providing a likelihood rather than a guarantee, or based on current data, this candidate has a 65% chance of winning the election. This isn't a form of evasion or hedging bets, it's actually a reflection of scientific honesty and rigor. The future in reality is not a single predetermined path, but rather a complex web of possibilities, each with its own likelihood. AI analyzes vast amounts of historical data, searching for patterns and correlations, then estimates, based on these patterns, how likely they are to repeat themselves in the future. So a 70% chance of rain, for example, means that in similar atmospheric conditions and patterns observed in the past, it rained approximately 7 out of 10 times. Understanding and interpreting probabilities allows us to weigh potential risks and rewards, ultimately leading to smarter, more informed choices, whether it's deciding whether to carry an umbrella on a cloudy day or developing a comprehensive contingency plan for a business venture. The real and substantial power of predictive AI lies not in its ability to eliminate uncertainty altogether, a feat that is often impossible, but rather in its capacity to quantify that very uncertainty, providing a framework for understanding its scope. By providing us with percentages, probabilities, and confidence intervals, AI offers a more complete picture, transforming what were once vague hunches and gut feelings into actionable, data-driven insights. This fundamental shift from a desire for absolute certainty to an acceptance and embrace of probability marks a significant leap forward in the way we approach decision-making in all aspects of life. Understanding and utilizing probabilities empowers us to reason more effectively and strategically about the inherent unknowns that surround us. The future, by its very nature, will always remain uncertain and somewhat unpredictable, but now, with the help of AI, we have the ability to measure, quantify, and ultimately manage that uncertainty with greater precision. And that's the true and transformative value of AI-driven forecasting and predictive analytics. To see how AI handles uncertainty, let's delve into a fascinating technique. Consider ensemble forecasting, a sophisticated method widely used in weather prediction. It's a powerful tool for navigating the inherent unpredictability of atmospheric systems. Instead of relying on a single model, which can be easily thrown off by slight variations, meteorologists run not just one or two, but dozens or even hundreds of simulations, each offering a slightly different perspective. Each simulation begins with slightly different starting points, reflecting the range of possible initial conditions. The result? What does this multitude of simulations reveal? A spaghetti plot, a visual representation of a fan of possible hurricane paths, each line representing a different simulation's prediction. Where the lines cluster tightly together, confidence in the forecast is high. The models agree on the most likely outcome. But where they diverge and spread out, uncertainty rules. The future is less clear and multiple scenarios are possible. This approach doesn't just predict the single most likely outcome as a traditional forecast might. It reveals the full range of plausible futures, painting a comprehensive picture of what might unfold. Ensemble methods, once confined to meteorology, are now central in a wide array of fields, from the complex world of finance to the critical field of epidemiology, helping us understand not only the most probable scenarios, but also both the potential upside and downside risks. In finance, for example, thousands of simulations reveal not just potential gains and lucrative opportunities, but also the potential for significant losses and market downturns. In public health, scenario ranges help policymakers prepare and allocate resources effectively for both the best and worst cases, allowing for proactive and informed decision-making. The core idea: embrace imperfection by exploring many possible outcomes, not just clinging to the illusion of a single predictable path. Ensemble forecasting gives us a richer, more resilient, and ultimately more useful picture of the future. It replaces the comforting but often misleading illusion of certainty with a more realistic spectrum of possibilities. That's how we prepare for more than just one path ahead and navigate the complexities of an uncertain world. AI isn't the only force in modern prediction. Enter the superforecasters. These individuals, identified in the Good Judgment Project, consistently outperform experts and even some algorithms. Their secret? Open-mindedness, comfort with uncertainty, and relentless self-correction. Superforecasters break complex problems into manageable parts and update their beliefs as new evidence emerges. They work in teams, debate assumptions, and track their accuracy to learn from mistakes. Their method is disciplined, evidence-based, and collaborative, not solitary genius. Superforecasters show that prediction is as much about cognitive skill as data analysis. They spot nuances and context that machines might miss. The art of forecasting, it turns out, is just as vital as the science. The future of forecasting isn't man versus machine. It's collaboration. Studies show that combining AI's data crunching power with human judgment yields the most accurate predictions. AI processes massive data streams, flags patterns, and runs simulations at lightning speed. Humans add context, interpret intent, and spot black swan events that data alone can't reveal. This partnership creates a feedback loop. Humans guide AI and AI challenges human biases. The result? Forecasts that are both data-driven and contextually aware. Human intuition is augmented, not replaced, by machine intelligence. Together they offer a more robust understanding of the future. Some questions defy data-driven prediction, like the impact of a new technology decades from now. Here we turn to structured human expertise, such as the Delphi method. Experts anonymously share and refine their forecasts over several rounds, converging on a reasoned consensus. Scenario planning, meanwhile, imagines a handful of plausible futures, not just one. Organizations use these scenarios to stress test strategies and build resilience. These methods don't predict a single outcome, they prepare us for a range of possibilities. When data runs thin, structured human judgment lights the way. Despite our advances, perfect prediction remains impossible. The main barrier, imperfect data. Every model is only as good as the information it receives, and our data is always incomplete or biased. Unknown unknowns lurk, and crucial variables may be missing entirely. Models themselves are simplifications. They're maps, not the territory. Even the most sophisticated simulations can't capture every nuance of reality. This isn't a flaw to fix, but a reason for humility. Predictive tools are aids to judgment, not replacements for it. They help us manage risk, not guarantee outcomes. Recognizing these limits makes us wiser users of technology. The quest for foresight is about making smarter decisions, not achieving omniscience. Embracing uncertainty is the first step toward resilience. Some limits to prediction are woven into the fabric of reality itself. Chaos theory, the butterfly effect, shows that tiny changes can lead to wildly different outcomes in complex systems. Weather, markets, and societies are all sensitive to initial conditions, making long-term forecasts inherently unstable. Then there's the prophecy paradox. Predictions can change the future simply by being made. A forecast of a crash can trigger panic and cause the crash. A warning about a flu season can prompt action and prevent it. Our predictions become part of the system, creating feedback loops that defy certainty. Even a perfect forecast can be undone by its own influence. This ensures that unpredictability will always be part of human affairs. The act of predicting is itself an intervention in the future. If perfect prediction is impossible, what's the point? The answer: forecasting helps us make better decisions, not guarantee outcomes. By embracing probabilities, we move beyond all or nothing thinking and prepare for a range of outcomes. Ensemble forecasts and scenario planning prompt us to build resilience and contingency plans. The combination of AI, human judgment, and classic methods gives us a powerful toolkit for strategic foresight. We can't eliminate surprise, but we can prepare for it. The future will always be uncertain, but with science, AI, and human wisdom, we can navigate it with greater confidence. We may never see the destination clearly, but we can take each step with insight and preparedness.